Before graphing the combined inequality that you see here, we need to solve each of the two individual inequalities for x. So let's start with the one on the left. Our first step would be to distribute this -3 through the parentheses, which gives us 5 minus 6x minus 3 is greater than or equal to 14. Simplifying the left side one step further, 5 minus 3 is 2, so we have 2 minus 6x is greater than or equal to 14. Isolating the x term, we subtract 2 from both sides, and negative 6x is greater than or equal to 12. But watch out for your last step. To get x by itself, we would divide both sides by -6. But remember, if you divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. So we have x is less than or equal to -2. Over on the right, our first step would be to combine the x terms on the left side of the inequality by subtracting 4x from both sides. That leaves us with 5x is less than 15, and we divide both sides by 5, so x is less than 3. So we have x is less than or equal to -2, or x is less than 3. Now we have a situation that looks just like the problems in the previous section. Our next step would be to graph each of these two inequalities just above the number line so that we can see what's going on before we try to combine them. For x is less than or equal to -2, we have a closed dot at -2 and an arrow going to the left. For x is less than 3, we have an open dot at 3 and an arrow going to the left. Remember to use long arrows. Remember that OR represents union. And the union of these two inequalities means that our answer will include everything that's mentioned in the two inequalities. So all we have to do is bring both of these graphs down to the number line and see what we're left with. So we have x is less than or equal to -2, along with x is less than 3. If you take a look at what we're left with, we have the graph of x is less than 3 on the number line. So our answer reads, the set of all x's such that x is less than 3.